Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, we are done with the pre-order and post-order traversal, and now we move on to the in-order traversal. Okay, so where I told you the in or pre or post actually is all about the route. So in the in-order, I gonna do the left. Okay, then the in says the route here, and then the right. Okay, so that's why we say recursively traverse left subtree, then visit the route, and then the right subtree. Okay, the route is embedded, sandwiched between the left and right. In the pre, we got to first read the route, then left and right. Okay, and in the post we say left, right, and route. And in the in order, it is inside, the route is inside, sandwiched between the left and the right. Okay, so you got to start from the root node. Okay, then go to the leftmost node from the root node in the left subtree, and when the leftmost node is reached, write it down. So you're gonna go to bottom. When the leftmost node is reached, then you're gonna write it down, because you're gonna write the left first, okay, before the root. Now then you got to go to the leftmost node is parent node, then write it down. Okay, that means because that will be because you have done the left, then you go to the root. So what I'm saying is you got A, if it is B, C is here, D is here, and so on. So you go to the left. Okay, you talk about this is a root now, but this has a left, so you have to read the left. Now this is the root now, but it has a left, so you have to read the left now. Okay, so you got to read this first, then you come back to its parent and talk about you got to read that also, you got to write that or read that also, because now you're the left root, and now you go to the right. So you talk about the right. That's why we're going to have the right subtree. When the leftmost subtree, then at that parent's right, talk about that. Okay, first leftmost, then the parent of that, and then it's right. And then you're gonna move same way. Let's take an example here. For example, this guy, we are taking this example in the beginning also. Let's talk about these things here. So I am saying that firstly the pointer will be to the root, so we have to do for left root and then right. Okay, so you got to go to the left first before you can read the A, that's the root. You got to go to the left. Okay, but when you reach here, our root becomes this. So before you can read it, you got to go to the left. So that means you want to print the D first. Okay, then you come back to the root, that is the B. Now then it's right. So left, root, and right. Now when you go to the root, this one, the pointer is here. Now this is our new root. Okay, now this is itself a tree, so it is the root, and before reading E, you got to read its left, that is H. So you're gonna read H, then you come back to the E, then you read the I. Okay, so you are done with the for the B, you have read the left subtree, you have read the root, and you have read the right subtree, and now you go backtrack to the A. Now here in the A, you have done with the left subtree, then you should do with the A, then you should work with the A, right? This is its left subtree done, then the root, so left root, and now go to the right. Now when you go to the right, the C, before you can read the C, which is the root itself now in this subtree, then you have to go to the left, that is F. Okay, then the root, that is C, and then the G. So this will be its right subtree, so of the A. So first go to the left, then read the root, then read the right. Okay, and you apply same thing to every subtree. Does it make sense? So, and we are trying to implement it the same way we did it in a previous video. We have a structure, and in this case, recursively you call itself in order, and firstly you send the root arrow left, so you are reading the left. Okay, then you're printing the root, and then you are sending the right, root arrow right. Okay, if you're not getting what is this, you got to go to the video where I have explained this stuff. Okay, we can do the same thing. This is the recursive approach. We can do it in a non-recursive approach as well. So here is the way we go to the non-recursive approach, where we use a stack. Okay, so you create a stack, push the root onto the stack. So firstly you push this very simple one, you push the root on a stack and set the root equals root arrow left. That means you're gonna root arrow left, I should put it here. You go to the left side and continue until you don't you got a null. Okay, now if root is null and stack is empty, then that means we are done. Otherwise you got to pop when it hits at the end. I mean, the pointer hits to the null, then you got to pop something from the stack. Okay, so pop the top node from the stack and set it as that will be our root now. Okay, and you got to print that, and then go to the right, root arrow right, then go to the right. So what I'm saying technically is like this, that firstly what I do, I'm at a P. Okay, now what you got to do is push whatever there is, this is because this is a root, push that into this onto the stack. So we have the stack, so A is on a stack, then go to the left. Okay, root arrow left. Now this becomes a root, push it, then go to the D, push it. Now our P is at the D. Now P will be P arrow left, but that's null. So when there is a null, you got to actually do what? You got to pop, right? Now we are here, P will have a null in it because P is called P arrow left, that is null. So when there is a null in the P, so what you're gonna do is, but you can't stop the algorithm because there is something in a stack. So we say if root is null and stack is empty, then you can return you are done. But something is on a stack, that means we got to do what? We got to do this thing. We got to pop the top, that is D. Actually you read that. Now the D is read, you print that or you read that, whatever you say. Okay, and you go to the D's right, but the D has nothing in the right. Again P has a null in it. Okay, because P is equal to P arrow right, this will happen. P equals to because this is we call it in this here root, or we call it here P equals to P arrow right, or in this case if it is root, let me call it as a root. Okay, root arrow right, but that is null. When the P has a null, we're gonna pop from the stack. So D is already popped, this is no more, so that means you got to pop the B now, and you just, when you pop, read it, okay, or print it. Okay, and this is now B is our root. Okay, so root is here, or in our case, simple case, I said P, right? Keep the P is the root, root is the P. Okay, now when the P is here at the B, what we do to it is same as here, right? That is this line of code 2, that you print the B, and whatever is on the right of it, that is our new root. Okay, then this is our new root, and you apply same thing to this, what you apply to the A. That means you got to push it, you push the E, so our stack will have A, now it will have E. Okay, and P will go to the left, P equals to P arrow left, now that is H, and put that onto the stack. Now P is go to P arrow left, but that's null. When there is a null, you got to pop. Okay, when you got to pop, you're gonna actually print that. Okay, so now I pop the H, that's I'm gonna print it. Okay, H is no more, but when you print it, you're gonna go pointer to its right. Okay, P is called P arrow right, but that is null. So when there is a null, you're gonna again pop, so you will pop E. When you pop, you actually read that. Okay, and whatever is so P, we have a new E is our root now. Now whatever is on its right, P will go to the right. P is called P arrow right, so P will be at this at I. Okay, and what you do to the P, same as the step 3, step 2, that you push it onto the stack. Okay, E is done, we know no more this thing. Now we have stack is only having A, and now it will have the I. Okay, and P is called P arrow left. Okay, but there is null, so pop it. When you pop it, you print it, and if it has a right, P is called P arrow right when you print it, but there is null, again the P has a null, so you have to pop the A as well. When you pop the A, you actually print it. Okay, and whatever is P will go to the P arrow right. When you pop, you print, and you put your pointer or root pointer to the right of that node, right? So that is the C. Now that our new node is C, so we apply same procedure to the C what we have done to the A. That means C is our root, so push it on a stack. Okay, and go to its left. P is called P arrow left, so we have an F, push that. P is called P arrow left, we got a null. When we have got a null, we're gonna pop it, so pop the F. And when we pop, what we do two things. We write that, okay, and we make our pointer to its point to its right. And when we make P is called P arrow right, there is null, so then there is null, we pop. So we're gonna pop the C. So when we pop the C, we do two things. Firstly, we print it and we make pointer to make it right. So P is called P arrow right, that is G. Okay, okay, so that G, now we're gonna push. So this is done, this is done. Now we have nothing there, we're gonna G, put G, put G on the stack. Okay, and try to go to the left, but there is null in it. When you're gonna null, you're gonna pop it. You pop it. Okay, and we're gonna two thing. When you pop, you print that, and the second thing is you make pointer point to the right, that is null. Now in the null you have a null and you want to pop, but in stack there is nothing because this is popped, stack is nothing. So we have this situation when there is a null in the pointer, root pointer, and there is nothing in a stack, so we are done. So we have read it as DBH because we have to go for in order. That means when you're trying to go for A, you got to go B, you got to go D. So print the D, then root, then go to right. Okay, but before printing E, you got to print H, then E, and then I. Okay, then you have done the left subtree, you're gonna go A, so print A here. So left subtree is done, printed A, and then you go to right side. Right side is first the F, left, root, right, so F C G. So here we are. So we are done exactly. This is how we do it with the stack. Okay, so hopefully you have understood it. If you haven't, you got to repeat it a couple of times maybe, and you will get it perfectly. Okay, so see you in the next video. Until then, ma salama.